So memory management in C. So as I told you that a program is combination of a program is a sequence of instructions, and combination of so many programs is called a software. Okay, application software, system software, utility software. So utility software, which will be generally which will come along with operating systems. Okay, system software like example operating system, which will be used to handle the system. So apps, application software, they are specific applications to uh, write the software for specific applications. So memory management in C, so we need to understand that it is very important. Generally what happens, so whenever we create a variable, already we have studied that what are variables. Okay, so the variables are nothing but they are the memory locations, computer memory locations. Okay, named with names, labeled with names to store the data. Okay, so computer memory locations are called variables. So whenever we create a variable, okay, it may be integer variable, it may be string variable, it may be float variable, it may be bool variable, whatever. So many variables we have discussed. So whenever we create a general basic variable, that moment what happens, C will automatically give somewhat space for that variable. Okay, so whenever we create a variable, so not only C, every language, because we are studying here about C, so generally we will speak about C, but all languages, because the variables is the common part of all languages: C, C++, Python, Java, HTML, CSS, in any languages, whenever we create variables, so somewhat space will be allocated for that automatically, that variable. So suppose if int variable, if we create int variable, so typically 4 bytes of memory will be allocated for int variable. So if a double variable created, double is what? Double means float variable. Okay, double float. So if double float variable is created, it occupies 8 bytes of memory. This means 8 bytes of memory will be allocated. So we can use the size of operator to find how much of memory allotted for a variable. So we can use size of operator. By that we can simply find that how much of memory allocated for different variables. Okay, so C, this is the code for C language. Here C, my int is a variable, my float, my double, my char, these are all variables. Okay, but which type of variable in C language, C, C++, Java, it is very important. We need to declare the variables first, because these are called these languages are called static type programming language. Static type means what, you know? So we need to first declare the type of variable. So my int is what? Int type variable. My float is float type variable. My double is double type variable. Double float means my char type variable. So my int means what? Variable, it stores integer type of data, all that negative and positive numbers without any decimal values. They are called what? Integer. All negative and positive numbers without any decimal. Okay, decimal values. My float, it is a float, decimal variable. It stores decimal numbers, all negative and positive numbers with decimal values. Okay, even though 2.0 2.0 number, it is a float number, okay, not integer number. So my double is also a float number to store more decimal values up to 15 digit, okay. My char is a variable to store character data type. So these are variables, okay. So now see what happens here. So printf, I have used printf. Within this size of operator, by using a size of operators, I can find out that how much of memory allotted for this my int variable, okay. So percentage lu is format specifier. Already we have studied in the previous classes what is format, what are format specifiers. Format specifiers, they will be used to, means format specifiers always will help the compiler. Now we are dealing with which type of data, okay. So next, by size of operator, my float variable, it will take 4 bytes of memory. My double variable will take 8 bytes of memory, because my double is what, it is a float, double float, okay. By size of operator, we can simply find that how much of memory it will be allotted for all these variables. For my character, my char is a variable. By size of operator, we simply find that 1 byte memory, okay, 1 byte memory, okay. So let us see now what happened here. So this is the way to find how much of memory will be allotted for all these variables. So here my int, it is what your wish. Variable can be anything, okay. Simply you can write my int x. If you write, there is no any problem. For my float, if you write y, there is no any problem. Your name you write, there is no any problem, okay. But at the time of using size of operator, that moment we need to change these also we need to change. So my in place of my int, I need to change this as x, okay. So float, my float, in this place I need to change this as y, because I have changed that variable name as y. So my double, my char, I have not altered them. So if you run this, there is no any problem. So you will get the as it is, what, 4 bytes for int, 4 bytes for int variable, 4 bytes for float variable, 8 bytes for double float variable, 1 byte for character. Understood that? So what about these format specifiers? This format specifiers, in this place, if I use I, otherwise D, what happens? See, D is what? D format specifier will help the compiler. Now compiler, you need to work with which type of data. So D for what? D or I for integers. Now let us see. In place of, okay, so here I can use I also. I and D both are for what? Integers, okay. In this LU, this is what, which type of data? This is float type, so simply I can use F, float. There is no any problem. Format specifier. So now see, it is giving error. So 0.00, there is no any value. So to know the memory size, that is LU. Using LU format space, that is bit better. Okay, so for character, if I change this format specifier as C, so let us see what happened here. If it gives error, so I want to, so it is not giving. So generally, whenever we want to know the size of any, how much of data, how much of memory it is being taken by that variable, so generally that moment use the LU format specifier. LU LU format specifier, that is very important to use here to know the how much of size, how much of memory is allotted for that variable. Okay, so this is very simple, size of by size of operator. So if one more I want to create one more variable. First of all, type of variable is equal to bool type of variable, and create B. So variable created. Now I want to know how much of data allotted for this bool variable. B is a variable and it is bool type, data type. Okay, so for this, how much of data will be, memory will be allotted for bool variable. So if I want to know that, same print f bracket in double quotation marks percentage LU. LU is a format specifier used to know the how much of memory will be allotted for that variable. \n to get new character, to get a new character, new line. Okay, to get new line. Okay, in every line we have used \n to get new line. Okay, otherwise, okay, all that result will be kept beside of each other. So if you want to get, now here which variable I need to call here, B. B is the variable which is used for Boolean data type. Okay, now one more bracket and terminate with semicolon. Now run this code. What happened? So why? Because I told you that in the previous classes, Boolean data type is not default data type. That moment we need to use one more we include one data that is library, that is called what? std bool. std bool is what? Okay, std bool is what? One more library that will be used to work with Boolean data type, because Boolean data type is not the default data type. So Boolean data type is not the default data type. So if you want to work with Boolean data type, so we need to include one library header file that is called std bool, so that we can work with Boolean data type. std bool.h indicates header file. Okay, so for the Boolean data type we will use 1 byte of memory. So these are our basic data types: integer, float, integer float, 4 bytes of memory will be allotted. For double float, to store more decimal values up to 15 digits, so 8 bytes of memory will be allotted. Character bool, for character and bool, 1 byte of memory will be allotted. Okay, so now come to the point. Now come to the point is where, so by size of operator we can find how much of memory will be allotted for every data type. So next is what, generally whenever we create a program, I told you that program is what, a sequence of instructions is called program. Sequence of instruction maybe 20 lines, 100 lines, 10 lines. Even though if we write 10 lines or 5 lines of code, it is called a program. So combination of many programs is big. If we combine many programs, it becomes a software. Software may be application software, simply called app, otherwise system software, to run the system, to manage the system, like operating system. Okay, so many linkers and loaders, they are part of operating system software. Utility software, generally the programs, the software which will come along with operating system. So you need not to separately load the operating system. You need not to separately load that softwares. So whenever you install your operating system, along with so many applications will loaded. Okay, will be loaded. They are called utility software. So whenever we create a program, so that occupies somewhat memory. It may be too much memory, otherwise unnecessary memory. So that moment what happen, if any program is created, if it occupies more memory unnecessarily, so by that operation, performance of that program, it may be slow down the performance of that program. So if any program is being created, if it occupies more memory unnecessarily, so its performance may be slow. Okay, so unnecessarily occupying of memory, we need to ensure that as a programmer. So whatever the memory to be allotted, so unnecessarily no any memory will be allotted to, we need to ensure that variables. Okay, unnecessarily if more memory is allotted for variables, so that program's function performance may be slow. Okay, that is called poor performance. As a programmer, we need to ensure that. Okay, that is very important. So in C language, we can manage the memory ourselves. As a programmer, we need to manage the memory. So it is somewhat complicated task. Okay, so it is also quite